Prototypes. This is one topic that JavaScript developers either fear using or don't know enough about. So we often end up with unnecessarily complex code, especially when parts of it are copied over from Stack Overflow or other similar sources. JavaScript is a multi paradigm language. That means that the same objective can be achieved through different coding styles. But having this flexibility does not mean that we should always keep on avoiding prototypes as long as we can. Someday, prototypes will catch up with you and push you into a corner. When that happens, let's be prepared to tackle it and turn the table in your favor. Writing object oriented code has traditionally been done using classes, like in C++ and Java. In JavaScript, you write object oriented code using prototypes. Unlike a class, which is a template for creating objects, a prototype is an instantiated object with functions and properties that can be copied to other objects. In this way, prototypes not only provide an OOP template, but also aid in inheritance. Starting from ES6, aka ES 2015, you can use classes to write OOP code, but it's just syntactic sugar. Underneath, the JS compiler will convert your classes into prototypal code. Let's dive right into code and see prototypes in action. All right, I'll use my VS Code setup to run some JavaScript. The code runner extension, this one, is a nifty way to run JS right inside VS Code. But you need to have Node installed. I'll start by creating an object that we want to use as a prototype. Let's first create a new file. And in here, I'll create the new object. Simple person object with only one property called name. And let's use a generic name. Looks good. Now let's create an object to represent a type of a person called developer. We'll set its prototype to person. And this is how we do it. Isn't that simple? Now, since person is a prototype of developer, its name property should be available in developer too. Let's check that. So we'll console.log developer.name. To run this piece of code, I can just press this button, but I'll just use the keyboard shortcuts. For me, it is Control Alt N, but you can configure it to anything else. So it outputted John Doe as expected, since developer's name was inherited from person. Now, before we move ahead, it's useful to note that proto is a setter for a hidden property called prototype. JavaScript won't let us set prototype directly, but let's keep in mind that's the actual name of the reference property. Now we can override person's generic name with something more suitable to a developer. Now, if we run the code, we should see developer's name. Isn't that beautiful? Inheritance works for methods too. So let's create a new method called speak inside of person. It'll be just a simple arrow function that will console.log something simple. And all we need to do is just call developer.speak and it should output hello, which it does. Let's try and override speak. And what better to output than the classic developer dummy text, hello world. Let's see if this works. And it does. We can make the prototype chain as long as we want. So we can create another object. This time it's me, and I am a type of developer, of course. I have my own name. And let's see if it's able to print my name. It's as expected. And how about speak? Is it that also available to me? In fact, we don't need the console.log. Right. It's coming from developer as expected. Value of this can be hard to infer in a sufficiently complex piece of code. JavaScript developers know this all too well. How do you think this behaves inside inherited methods? The short answer is as expected. Let's see for ourselves. Let's create a method to return the name. Let's go back to our person object and we'll add a new method called tellName. It will use the name property somehow. And also notice that I've created a regular anonymous function, not the arrow variety. This is required to make this work as expected. For more context about how this works inside an arrow function, I encourage you to see some articles online, some good ones on MDN. Now let's see how this behaves. So we'll just call this new method. It does work as expected. So this .name is picking up John Doe. But how does it work for a developer? Because that's the inherited part we were talking about. So this .name inside developer is now referring to Joe Doe and not person's John Doe, which is exactly what we wanted. Let's do something a bit more involved. We'll create a new property called date of birth that we'll access via its getter and setter methods. Going back to person, we'll add the new property and it will be a date object. We can put a random date for now. And now let's create the setter and getter for DOB. So the setter is a function that takes in a string value and sets this .dob to a new date object using that value. The getter is even simple. The names have to match. And that should do it. So this will return the exact date object, which may not print well. Let's try the toDateString method so that we read something human readable. Now the object Anurag should also have inherited the new property and its accessor methods. Let's try them out. Let's first set Anurag's date of birth. And remember, this is going to be a string because we're going to parse it in the setter. Not that I'm that old, but hopefully you get the idea. Let's console log. And as we said, it works as expected. And we see a human readable form of the date object. So although we set a different date in person right here, the one returned above is the one for Anurag. Even with inherited methods, this is always the object before the dot. I hope you also noticed that our last assignment, this one, did not override person's setter method implementation. This is unlike how we override the speak method here and is expected behavior for setter methods. Sometimes it's useful to know which properties were defined in an object and which ones were inherited. We can check this using the built-in hasOwnProperty method that every object in JavaScript inherits from the master object called, well, object with a capital O. Let's define a brand new property in our object Anurag. Let's first comment these out because we'll not need them for the time being. And here, let's define our new property. Let's see what hasOwnProperty has to say about this new one. As we would expect, it returns true because we just defined it here. Now let's see what it has to say about the inherited properties. So let's check first for name. It's true because, yeah, we are overriding name here. And let's see what it says for speak. Well, that's false because speak doesn't exist in Anurag. It's coming from the master parent object called person or even developer. It should be the same story for tell name. And date of birth. As expected, they both return false. Now here's an interesting twist. Let's uncomment this line. We probably don't need this anymore. And let's see what it has to say about DOB now. It now returns true because date of birth setter method has set the DOB object on Anurag. See, here we are setting this .dob and this assignment just happened inside the context of Anurag object. On a related note, when you want to iterate on an object's properties, use the object.keys method to get only owned properties. So if we do a console.log for object.keys for Anurag, we get only name, play tennis, and DOB, the only assignments made inside Anurag. We can use the for in loop for own plus inherited properties. So if we put a new for each block here, this returns all the properties, owned plus inherited. We previously saw that every object in JavaScript inherits has own property method. But where did that method come from? When we initialize an object, JavaScript sets its prototype to object.prototype. It is this built-in prototype that contains has own property and toString and a few other methods. Let's go to browser and see object.prototype for ourselves. It has this has own property method that we were looking for, and also some other very common methods like toString or is property of. We can verify that Anurag's has own property is also coming from object.prototype. Let's check if it is exactly equal to object.prototype.has own property. And as expected, it returns true. There are other built-in prototypes, such as we have array.prototype. It contains all the built-in array methods like fill, find, flat, for each, index of, and so much more. Similarly, we have function.prototype to define something common and interesting. So we have apply, bind, call, and let. And finally, we have date.prototype, of course. It is possible to modify built-in prototypes. You can add properties to be inherited by derived objects. You can also redefine existing properties. For instance, let's say that you want toString to behave differently from its default implementation. So let's console log anurag.string. And as you can see, it doesn't print very well. So just before console logging, let's override the implementation of toString. And here, let's return this .name. Now this time, anurag.toString returned the name correctly. But modifying built-in prototypes like this is not recommended, as it may have unintended consequences. Let's create a new object to see what I mean. So we'll create Rahul. It's a simple object with only one property called age. Let's see how console logging Rahul.toString works. As we would expect, it returns undefined because Rahul doesn't contain the name property. So you see, we overrode the toString for all possible objects here. And we were expecting all objects to contain the name property. And that's why this method here returned undefined. The only time you should be modifying built-in prototypes is for polyfilling. Polyfilling is a term for making a substitute for a method that exists in the JavaScript specification, but is not yet supported by a particular JavaScript engine. For example, before 2015, the string method starts with was supported in Firefox, but not in Chrome. Back in the day, it was common to see polyfills for it such as this. So here, first we check to make sure that starts with does not exist in the browser. And when that's true, we supply a default implementation. And this is not exactly the same as the one in the JavaScript specification, but probably a little closer. Okay, we learned quite a bit about prototypes. Let's summarize what we learned. A prototype is an instantiated object with functions and properties that can be copied over to objects. An object can specify its prototype via the proto property, or the more modern equivalent object.setPrototypeOf method. We can override a method's implementation from prototype in a derived object. We can make the prototype chain as long as we want, even with inherited methods. This is always the object before the dot. Use the hasOwnProperty method to check if a property was defined in an object or whether it was inherited. JavaScript provides built-in prototypes for object, array, string, function, and more. You can modify built-in prototypes, but do that only for polyfilling. With that, time to say goodbye. Hope you learned something new today. See you in the next one. Adios.